presentation content will just briefly look at the CSIR. I will introduce the organization where I come from for a specific reason. You will see when I do that why. I will talk about the global trends in the building sector specifically and the role of the CSIR, of the 4IR. And also I will then sort of look at the perspective or give a perspective of the CSIR, and then I will conclude. I hope it will be a fairly short but hopefully meaningful presentation that will help us to discuss. First of all, the CSIR is a government research council, and it's not a private sector, and we are funded partly by the government as well as the other money. A big chunk of our income comes from us selling our products, our technologies that we develop. And the main client happens to be the public sector. Very little of that goes to overseas and some bit goes to the private sector. But we're trying to change that picture. I'll discuss that a little bit as well. CSIR 74 years old this year, close to 3,000 employees. And I'm going to skip the rest of the information. We are part of a family of research councils, as you can see them: mining, mineral processing, MinTech, National Research Foundation, the Water Research Council, etc., Medical Research Council. We are part of those. We're probably the biggest of those in terms of the number of employees that we have. We've got quite a good footprint as well overseas, and quite a big organization in terms of research. So what exactly do we do? Let me try and summarize this. CSIR conducts multidisciplinary scientific and industrial research, development, and innovation. So we cover a number of sectors. So we're not just about one sector. We try to spread our research quite a bit. We develop, test, and pilot new technologies, and we provide technical advice. And after having tested those technologies, we do not offer financial assistance, nor do we provide training, but we do work with partners in trying to propagate our knowledge. And even in training, we do delve into training programs a bit, but it's not really a main thing that we do. In that case, we work with universities and to disseminate information. We are positioning to play a much bigger role in industrial development. And to this effect, I just want to share information about the CSIR. We are currently undergoing quite a hectic restructuring program. The main goal of this program, the restructuring program is called Project Synapse. The main goal of it is really, as we say it, we amplify the I in the CSIR. What does that mean? We want to promote industrial development. We don't want to do research and put it on the shelves and it rots there. We want to really engage this time around with the industry, people like you, and take our technologies there, localize the technologies that we may have partnered with our overseas partners so that they make a meaningful impact on the ground. So that's what the I is all about, and that is maybe said easier than done, because it involves quite a lot of relook at our business model and our operational model and things like that. In fact, our vision and mission has actually changed drastically. But that's the main thing. We want to reposition ourselves so that our research actually has got impact. We can, that we can be impactful. Now, about the fourth industrial revolution, the CSIR has identified very, very strongly that it will use these technologies, and I am not going to go through them. We have heard about them all day today. But I just want to say that, just to contextualize, when I talk 4IR, I'm a little bit broader than just digitization. I'm also looking at the products themselves. How are they developed? Then you can link them up to digital platforms and softwares and that sort of thing. And you'll see what I'm talking about later. So I think perhaps the good news, to be just modest, is that the Center for CSIR, which the President has been talking about, is actually going to be hosted at the CSIR. So we're quite happy that we will be hosting the Center for CSIR. It will be launched soon this year. Right, I think that's really a lot to say about the CSR. Just to give you a taste of the technologies and projects that we have. For example, we do have a big facility to do additive manufacturing or 3D printing. You would have seen maybe outside here there is a 3D printing that uses concrete to do a house. Ours is more on the manufacturing side, where we can use titanium in particular to print parts, whether they for aeroplanes and for replacement of body parts and that kind of thing. So we do quite a bit of that. We also have a robotics program. Some of the examples are a robot that we use for deep mining. You know, when you go deep, especially the gold mine, they're so far deep that getting workers into some of the corners around there can be dangerous because of gases and stuff that is emitted there. So we send robots to detect, take samples, and all those type of things. So we have a strong robotics artificial intelligence program. We also have a robot that dispenses medicine in pharmacies and in clinics and hospitals. So I think that was showed in Parliament the other day when CSIR was exhibiting in Parliament. So we were showing some of these technologies. Sensors technologies, we've got a lot of that. For example, in buildings, we can deploy sensors to pick up bacteria from the carbon dioxide that we breathe, see how much TB, especially in prisons and in public spaces. We can use those kind of sensors to detect harmful bacteria. We have a lot of decision-making systems and tools. Data science, we've got a Meraka Institute, which specifically just look at those ICT systems to look at data science. We've got one of the highest, the most powerful computer, supercomputer in the continent. It's sitting with CSIR, and we use that for processing massive amounts of data. Software for automated machining and operations like milling and drilling. This is just a suite. I will talk specifically later about the building sector. Okay, this slide here. So those are different sectors. But in terms of building, and just to give a perspective now of, this is the global picture. It's been said here today. Really, a lot of countries, especially developed countries or first world countries, what you call them, whatever you want, are moving away from brick and mortar. They are into these kind of technologies as you see them on the picture, where a panel is developed inside the factory. Sometimes the whole house is developed in the factory and lifted up and put on site. That has got a lot of ramifications for employees, for the actual process itself, because for one thing, there's very few workers on site because everything is now on site. Now, if you look at it, you can say, but now you are taking work off the site, for workers. But on the other side, you can also say you are moving people from the site to the factory. So there's that changes. There are a lot of advantages. I'm not going to go into the advantages. This is another picture of the housing. Can you believe this is Toyota doing these things? Toyota, they're using their knowledge of understanding the production line of a car to actually build a housing unit, and you get all these panels, and at the end of the line, they assembling this thing and they lift it up and they go and put the the unit, the house on the site, and they can stack it into a multi-story house. So these are the things that are happening elsewhere. I think it also reflects this thing that the technologies are now can I use the word intermarrying? They are overlapping, and the borders are very difficult to actually delineate with this 4IR. We heard a lot about BIM. I really don't want to talk about it. It's a big development in other countries. We still need to catch up. We have heard about the advantages of it, and it's unavoidable. We have to go there. I think I just want to say there are downsides to all these things, and we must be very careful, especially when we look at policy and we are advocating policy changes, that we have to be, we need to be able to pick up the risks that come up with these technologies. And some of the risks have been mentioned today here. One of them is that employment, or the shift of employment from one skill to another, which means we need to train people. But there are other risks, and we need to study them very, very carefully so that we don't just buy in blindly. My next slide is also covering innovative building technologies. I'm not going to go into detail in terms of the benefits. Their speed in the main thing. Cost of production comes down because you're working so fast now. The quality, the finishing of the building becomes better. I just want to now cover what CSIR is doing specifically in the next few minutes. And we're doing a lot, and I think this slide actually shows that we're doing quite a lot. I'm not going to try, I hope, and you can read this, but this particular roadmap is the Science, Technology and Innovation for Sustainable Housing Human Settlement. Sustainable Human Settlement. It's a 10-year program that we are running at this CSIR. Essentially what we're looking at the problems in the human settlement, the built environment, and we're coming up with solutions to a number of problems, whether it be the type of houses. Some of the issues talk to the smart cities aspects that we've heard about today. Basically trying to make things smarter, more intelligent, work faster, safer, all those kind of things. So there's a lot that is happening in that space. I also want to, sorry, I'm operating two things here. This slide really is looking at, on the extreme right, this massive, I'm just trying to make an illustration, a model. 4IR coming up on the left, this conventional building where we still, most of us are working at. And my proposition is that the way we're going to bridge this gap, one of the things is what that we need to do is to look at the innovative building technologies, that small bubble at the back there. And we're learning a lot from the manufacturing. I think Prof has mentioned the whole manufacturing things. Manufacturing is teaching us a lot of things. Essentially what one is saying here is that the brick and mortar as we know it, we are moving from that world. Yes, we're still working a lot in that level, but we are moving gradually from that to innovative building technologies and obviously digitizing and all those things. And that's what we have also adopted at the CSIR as part of the research agenda going into the future. Typically, this is one project that we are running. We are developing this platform, modular housing platform, same as the one I showed you about the Toyota. We're trying to emulate that example. We want to use timber-based materials for walling, for platforms. We want to use CLT, which is cross-laminated timber as a material. The reason we are using timber is that if you look at the timber industry, they are saying they are wasting about 50% of the tree, essentially. 50% of the product actually gets wasted when they cut the tree. So timber has a lot of promise in terms of we can take that waste, whether it's sawdust or what, and use it to process it to things like cross-laminated timber. But we're still working the modalities and exactly how we're going to do that. But part of it as well is we are going to deploy 4IR technologies. We're talking about computer-aided design. Sorry about this. I've been talking all along now. You are not in the picture. This is the unit that we're working on at the CSIR. We are going to look at the computer-aided design, computer-aided manufacturing, and how it links with the BIM, which the prof and Joe has been talking about, to actually marry these two technologies from construction and from manufacturing. So that is one project. The other project, this looks like a very simple brick and paver. In a sense, it does the same thing. These are bricks and pavers. But what's different about this, it doesn't have the OPC cement. You know, the cement, when you're mixing, there's no cement here in that sense. So we've used fly ash. We're using geopolymers to produce these products. Using fly ash has got advantages in the terms of the environment because it's dumped by ESCOM. Lots of mountains of fly ash that we are using to actually produce something like this. And if you look at the strength of these things, it's as good as any brick. So there's also, in terms of 4IR technologies, nanotechnology, that are, I'm sorry, but this is, I'm talking about these bricks. Fly ash as well as geopolymers, different clays that we can dig up. There's a very interesting project in Limpopo that we did to identify clays, and we need to go into those communities, talking about now LED, to actually empower people to say, with the materials that we have locally, we can actually use up these materials, these special clays, and do our own bricks, our own pavements.